Alright, welcome to Drive-Thru Confessionals, a special pre-calculus version. Hungry for lunch? Stop by the deli. Get yourself a sandwich. That's just me plugging the deli. You know how people do that now? They plug things, so I'm just plugging some imaginary deli that makes sandwiches. Alright, I will. I'll plug you someday, cool. Okay, so today we kind of start our second semester out with trigonometry. It's a very important subject. Trig is the study of triangles. That's what trigonometry means. Just think about that triangles are such an important shape that they created an entire math course specifically for triangles. Why are triangles important? Well, one thing is this concept of triangulating. Okay, and triangulating means if I know the locations of two things, I can always find the location of a third missing thing. And you might think, like, well, what the heck does that have to do with anything? Well, mostly with GPS. That's why triangulation is so important. So when you have your phone in your pocket, it's sending a signal. Okay? So you are a defined location. Someone knows where you are. The satellite, which orbits our Earth like about 20 miles above the ground, that also has a known location. The satellite knows where it is. It's smart like that. So here you've got you've got the satellite, okay? And then using those two pieces of information, you can find your way anywhere, and that's exactly how GPS works. It triangulates. It keeps track of the distances between you and the satellite, and the distance between the satellite and your desired location, and it just literally permanently, like every single microsecond, it's changing that data so it charts you to the right path. It's amazing stuff. Okay? And then the other way you can make that work is, let's say where like we talk about it in forensics, and that there was a murder that occurred somewhere at a certain time, and that piece of information is known. And again, so now you got a known location. The satellite would be another location. They could track everyone's phones to see which people crossed through that point at that time, and they could use that as evidence. Although, if you read a lot, you'll know that the new iOS system, or iOS, does not allow them to get into your phone, and that's being argued in court right now, whether they're going to allow that to be evidence and force, like, law enforcement to be able to get into your private information, or whether or not they're going to say, no, that's unconstitutional. So stay tuned for that. Okay, but we'll just start real simple with two pieces of information. And those are vocabulary words. So we have legs and hypotenuse. Okay? Anyone know how to define the hypotenuse? Yes, very good, Jimmy. The longest side of a right triangle is the hypotenuse. How do you know if it's the longest side? It is across from the biggest angle. The biggest angle in a right triangle is always the right angle. So that's the hypotenuse. The other two sides that form the right angle are called legs. Okay? And so, like, a long time ago, this guy, Pythagoreas, who probably looked like Moses, okay, came up with this equation, and it turned out that it's always true. And it's kind of been a foundation for many maths that followed this, okay? And that was leg squared plus leg squared will always equal the hypotenuse squared. But Pythagoras didn't write it like that. He said that in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. And then we have turned that into how you guys remember it, which is a squared plus b squared equals c squared. Does that look more familiar? Now, why do you think I prefer leg squared plus leg squared equals hypotenuse squared to this formula, which is a squared plus b squared equals c squared? Anyone know why I prefer this version? Okay, what'd you say, Jimmy? clarity. God, you're on fire today, Jimmy. That is excellent. That is exactly why I prefer it. See, sometimes students forget in this example what A, B, and C stands for. So then they put things in the wrong place, and then they get the answer wrong. Here's what you need to know. C is always the hypotenuse, so it must always be longer than A and B. Sometimes you will be filling these in for A, sometimes for B, and sometimes for C. Let's do a couple examples. So let's say find X. Go. See if you can find that right now. I'm going to give you a minute. Okay, let me walk you through that. Okay, I started with the Pythagorean Theorem. Okay, we are missing our hypotenuse, so X represents our C, our hypotenuse, our biggest side. Okay, then I just did a bunch of algebra. Here I crossed out the negative version of an answer because you can't have a side length that's -5. So we end up getting X equals 5. This is called a 3, 4, 5 triangle. It is the most famous shape in the history of the world, the geometric world. So I call it the Michael Jackson of right triangles, or the Michael Jackson of triangles. The reason I call it Michael Jackson is it can look like a lot of different things. Okay? And I think Michael Jackson looked like a lot of different things throughout his life. You guys don't know this because he died before you guys were old enough to understand things like that, but there was a time in his life where Michael Jackson was the most famous person in the world, more famous than any presidents, anyone else. Everyone in the world kind of idolized him. All right, let's do one more. It's the Pythagorean Theorem. That's what we're doing. Okay? Okay, let's do this one together. What's different about this one compared to the last one? We know the hypotenuse. Very good, Ashley. So now we would say 30 squared plus x squared equals 50 squared. Now, you might think, well, how do we know this was A and not B? We don't. So you could totally have x squared plus 30 squared equals 50 squared. It would not matter. Okay? Anyone know what 30 squared is in their head? It's 900. Well, now that I told you what 30 squared is, would you take a guess on what 50 squared was? Very good, Lisa. 2,500. Okay. What's my next step here, algebraically? Do I subtract or square root right now? I do subtract. So I'm going to subtract 900 from both sides. I get x squared is 1,600. Anyone have an idea what the square root of 1,600 is? It is 40. Okay, so check that out. In this one, x is 40. Well, remember, I called this the Michael Jackson of right triangles. Michael Jackson sometimes looked like a man, sometimes he looked like a woman. Sometimes he looked white, sometimes he looked black. He can look like a lot of different things. This is, once again, the Michael Jackson of right triangles. What's the difference between the first one and the second one? We just multiply by what? By 10. So 30, 40, 50 will always be a right triangle. Okay, it's the most famous one. There are other ones. We will learn them. But I'm just trying to give you guys a good intro into right triangles. everybody comfortable with the Pythagorean Theorem? So it started out with the Pythagorean Theorem, okay? And then somebody else was like, well, hold on. We can do even more with this. So they used the Pythagorean Theorem to invent or discover, depending on how you think about mathematics, because it was always there. They just kind of figured it out. That's why I don't know if you call it an invention or a discovery. But they figured out these three trigonometric functions, trig functions. A function is just an operator like multiply. That's a function. Divide. Well, sine, cosine, and tangent are just functions. Okay? And so, in order to understand these right, we have this really famous acronym or mnemonic device. Does anyone know the acronym to remember sine, cosine, and tangent? Sounds like a Native American chief. SOHCAHTOA. Okay? So, what does that mean? Well, it's really telling us some stuff. You guys are going to write this on the top of your paper for like the next 3 weeks. You're just going to get used to it. It stands for the sine of an angle is equal to the opposite side divided by the hypotenuse. Hypotenuse. Okay? The cosine of an angle is equal to, does anyone know the word for your next door neighbor? Not the neighbor across the street from you, but the neighbor next to you lives blank to you. What is that word? It starts with an A. Not across, that would be adjacent. Somebody said it. Okay? So that is adjacent over hypotenuse. And then the tangent of an angle is equal to the opposite side over the adjacent side. I abbreviated there. Is everybody with us right now? Okay. So, if this is our angle, we're going to start calling that theta. Remember, I made you promise that you're not going to get intimidated by new notation. This is just a Greek x. It looks like an x. Treat it like an x, but we're now going to call it theta. Okay? Well, shoot, that's not even theta. Sorry, theta. That was alpha. Okay? Just another Greek letter. All right, so let's say if that's our angle, then this would be our opposite side. We know which one the hypotenuse is. It's always across from the right angle. So this is our hypotenuse. And that makes this side that's right next to the angle but is not the hypotenuse. So if it's next to the angle but it's not the hypotenuse, then it's the adjacent. Did you just figure something out there? Adriana, did you just figure something out there? Oh, I could tell you the date he died, I bet. Because he died on, I know where I was when he died. He died on like August, was it July? Is it June? I was at was it June, really? Of 2009. So I named my son Marley Jameson, thinking that we were going to call him MJ, because I always liked MJ. And then after he was born, we looked it up. He was born on Michael Jackson's birthday. How about that? August 30th? Or August... No, his birthday. Look it up. I don't know when it is. Okay? That just proved you I don't know my son's birthday, but it's somewhere around there. Okay? All right. So, maybe this doesn't make a lot of sense to you yet. So we need to do an example, okay? How can we use trig? We can use it anytime we have a right triangle and we know two pieces of information about it. We can find every other thing about that triangle out. So let's do an example. Let's say solve the missing triangle. Solve for what is missing. Oh, how about 12? Okay, so we got a triangle. How many pieces of information are there in a triangle? There are 6. 3 sides and 3 angles. What does this mean? This one's 90. So really we are only missing one angle. We'll find it later. Let's call this X and this Y. We could have called it B and C. It doesn't matter. Okay? According to the 25, what is the 12? Is it opposite? Is it adjacent? Or is it hypotenuse? It's not the hypotenuse. What's this arrow you think pointing to? It's opposite. Okay? And what is the Y? The hypotenuse. If we look back, which one involves opposite and hypotenuse? The first one. So we are going to do sine for this one. To find Y, we will use sine. Why are we finding Y first? I just picked it. It doesn't really matter. So sine of the angle, so that's 25, is equal to opposite 12 over hypotenuse, which is Y. Okay? What we do is we just turn these into proportions. So we put that over 1. We cross multiply. You get 12 times 1 is equal to sine of 25 times Y. So now you know that Y will equal 12 divided by the sine of 25. Can somebody do that in their calculator, please? You get Y is 28.4. Did I do that right? Okay. All right, now, so let's write our answers for the unknowns in blue. 28.4. Okay. If this one's 25 and this one's 90, how can we find our missing angle? The quickest way, won't these two angles right here always have to add up to 90 in a right triangle? Because this is always 90. So the quickest way to find that angle is to do 90 minus what? Very good, Cole. And 90 minus 25 is 65, I believe. So that's 65. And now we have one more missing piece. And the cool thing about this is we could find it at least 4 different ways. So what is our final missing piece? X. I would recommend just find it with Pythag. You guys are really good at Pythag. It's quick. So now that we know what Y is, we can use Pythag. We can say 12 squared plus x squared is equal to, what's our hypotenuse? 28.4 squared. Okay? So we say 144 plus x squared is, help. Anybody got that? 806.56. And it's always good, I like how you told me that, Lisa, we'd rather round at the end. Okay? So now subtract 144 from both sides. And you get x squared is, help me out with that, Lisa. And now we square root both sides. Thank you, Amy. 25.7. Now look, after you're done with these questions, you always check to make sure everything makes sense. So is the hypotenuse the longest side in our answer? That's good. That tells you that you are most likely doing it right. There's another thing to check though. Is the smallest angle across from the smallest side? That's your checks. If you answer yes to all those questions, you're doing these right. Okay? So now you've kind of gotten an introduction or a reintroduction for many of you into trig. Trig today involves words, so I hope you understand the following words. Legs, not like as they apply to your body, but as they apply to right triangles. Hypotenuse, opposite, adjacent, sine, cosine, tangent. Those are the words we need to kind of understand right now. We don't have to be perfect at them, but we need to be comfortable trying to understand them. Sound good? Thanks for listening. Check back in. Boom.